Welcome back to Swell Academy. Here's a video talking about a system of equations where you're given two separate equations, both with multiple variables. And what we're going to do is use some graphing and see what does it mean when two lines intersect. So we've seen in the past this idea of, okay, we have an input and an output of our x and y here. And we've put these into tables and seen or taken a look as to what some inputs might do when put into a function. For instance, if we're putting in 0, 1/2 times 0 plus 1 is 1. 1/2 of 1 is 0.5 plus 1, 1.5. 1/2 of 2 is 1. 1 plus 1, 2. And we're seeing this pattern, as we've seen, where this is going up by 1/2. If for each plus 1 or increase of 1 unit in our input. So we've been able to identify patterns, also starting points, what happens when our input is 0. Now what we want to do is take a look at these functions and see if there's some connection as to when an input, let's use the same inputs here, 0 through 4, and I've set this up to be a nice way to show the connection here. And so if we're putting -2 times 0, 0 plus 11, 11, -2 times 1, -1 plus 11, that's 9, 7, 5, 4, -2 times 4 is -8 plus 11, that's 3. And again, we've seen a pattern here. It's decreasing by 2 for every increase of 1 unit of input. Our output is decreasing by 2. But the connection is seen or pops out when we see this idea here. Wait a second. 4 and 3, when we have an input, when our x is 4, our output is 3 for both functions. For both functions. There is a point at which each function has the same output when the same input is put in here, 4 and 3. Now, it's a little bit of a longer way using tables, but what we can do is come across this idea of, well, why don't we look at what happens on a graph, and maybe we can use that and visually find something to make this connection. Now, if you're going to make a connection between two functions and its input and outputs, it's probably best to maybe find a connection of both lines. So we'll use our same little bit of different way of graphing this. We'll think, okay, if x is 0, my y is 1. And I have a growth or pattern of, let's say, up 1 over 2 in our x here. Up 1 over 2, up 1 over 2. And we have this 4, 3 point here. And we've graphed this line here. And we can see it is basically going up a half unit for each plus. Now we want to look at this other function on the right here and see if there's any connection to the one on the left. Although we did kind of see there is some connection in the previous slide. And, you know, we look at the same way. What's my 0? Basically, when x is 0, my y is 11. That's my y-intercept, so I can graph that there. And then we're looking at our growth or slope, -2 over 1, down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. And we have this relationship again, this 4, 3, this intersection of two lines, where a coordinate can satisfy two equations in a system at the same time. And we could prove that by showing, well, y equals 1/2 times 4 plus 1, 2 plus 1, that's 3. Y equals 3, okay.
that works for this function. Y is equal to negative 2 times 4 plus 11, negative 8 plus 11. I have y equal to 3 again. So here's a way of solving a system of equations by using the information given in the y equals mx plus b, seeing if we can derive an intersection of those two lines from that, and then in fact coming up with a solution for both where x equaling 4 will result in a 3 for each.
Okay, so now we could use that idea, all right? We have two lines that intersect. That intersection is a solution to two equations. And look at these two equations here and say, okay, I know if I find the intersection of these two lines, I can find a solution. But first what we need to do is get that y equals mx plus b setup we had from the previous. So a little bit of algebra incorporated here, another little added layer, little added step. And if we're adding 6x to both sides, and the intention here is to get y by itself. We want it to look like this. And then we divide both sides by 2. We get y is equal to 3x plus 5. Now we have that slope as 3 and y-intercept as 5. Now we have that set up there. And we could do the same with this here. Let's move our x. 2y is equal to 2x plus 18. And then we're dividing both sides by 2. We have that x plus 9. And again, we have that slope of up 1 over 1 and a y-intercept of 9. We could graph both, start at 5, go up 3 over 1, up 3 over 1. Give ourselves a line here. And then same with the other line, start at 9, go up 1 over 1, up 1 over 1. We see again an intersection, that intersection being 2 and 11. And if I were to plug in, would 11, my y, equal to 2 plus 9, 2 being my x, 11 equal, that would be correct. So that is the solution to this function here. What's same as a function here, 2 and 11? Well, if y is 11 and I plug in a 2, 3 times 2 plus 5, I do have that 6 plus 5, and we have that 11 is equal 11. And again, here's an idea where we have a system of equations, multiple variables, hard to solve for two variables, but if we have a system and we can match up or connect these two functions, then we could in fact find a solution to both these equations. And the fun part here is that alone this function, alone by itself, has many solutions to it that we could use, that could fit. But in order to, once we add, like I said, once we add that second function here, there's all of a sudden this connection that there's this possibility of, well, if we can get these lines to intersect, okay, well then maybe we have a definite answer for both these functions. I hope this helps. Make sure you practice. Hard work pays off. See you on the next one.